Hi there, it's Miss Laman here, and today we're gonna talk about statistics. So let's get started.
First of all, let's talk about two main parts of statistics, average and range. An average is a way of representing a whole set of data using just one number. There are three different types of averages: mode, median, and arithmetic mean. Mode, in other words model value, is the most frequently represented value in the list of numbers. For example, we have a set of numbers 5, 7, 7, 8, 9, 7, 10. As we see, here the most frequently repeated number is 7, so the mode is also 7. Another example, the set of numbers 4, 4, 8, 15, 8, 9, 10 has two different model values because both 4 and 8 are repeated same number of times. Both of them are repeated 2 times. Median is the middle value of the list of terms written in increasing order. The median splits the data in halves. Half of the data are less than or equal to the median, and half are greater than or equal to it. To find the median in a list of n values written in order, we use a rule, where n plus 1 over 2 is exactly the position of the median. For an odd number of data, the median is one of the data. Suppose that we have a set of numbers 5, 3, 7, 2, and 10. At first, we should write all of these numbers in increasing order. So we will get 2, 3, 5, 7, 10. As we see, here we have 5 numbers, so by the rule, 5 plus 1 divided by 2 equals to 3. 3 is exactly the position of the median. It means that median is the third value. 1, 2, 3. So the median is 5. For an even number of data, the median is the average of the two middle values and may not be one of the original data. Assume that we have a set of numbers 3, 7, 4, 8, 10, and 12. And as I said before, first of all, we should write all of these terms in ascending order. And we will get 3, 4, 7, 8, 10, and 12. Here we have 6 numbers, so 6 plus 1 divided by 2 equals 3.5. It means that the median will be average of the third and fourth values. So, third value is 7, fourth value is 8. And the median is 7 plus 8 divided by 2, which equals to 7.5. Arithmetic mean is the sum of given numbers divided by the amount of these numbers. For example, we have a set of numbers 3, 7, 4, 8, and 13. To find arithmetic mean of these numbers, we should add up all of them and divide by their amount. So it will be 3 plus 7 plus 4 plus 8 plus 13 and divided by 5, which equals to 7. The range shows us how spread out our values are. In other words, this is the difference between the largest and smallest values of the list of numbers. For example, we have a set 5, 12, 3, negative 7, 2, and 23. As we see, here the largest value is 23, the smallest value is negative 7. So, range equals 23 minus negative 7, which equals to 30. Averages for grouped data. If our data is grouped, then we can only estimate the mean using the midpoint of each group. For the median, we can only say which group it lies in, not the exact value. And instead of a mode, we can only find a model group. Take a look at an example. The table shows a summary of the times taken by 20 people to eat 3 crackers without having a drink. Let's find the model group. The model group is the one with the highest frequency. Here, the highest frequency is 6. So, model group is between 70 and 80. Overall, we have 20 values. It means that our median will be average of 10s and 11s values. Here we have two values. 2 plus 3 is 5. 5 plus 6 is 11, which means that both 10s and 11s values are here. So the median is also in the group between 70 and 80. Estimate for the mean. At first we should find midpoint of each group by adding together the highest and lowest values and then divide them by 2. Now let's use the midpoints instead of the actual values. For example, 55 repeated 2 times. It means that we should multiply 55 by 2. Here we have 110. Then 65 repeated 3 times. So 3 times 65 equals 195. And etc. for each group. Then estimated mean will be sum of all these values divided by their amount. So we will get 79.25. Stem and leaf diagram. Suppose that a class earned these marks on a test. Write the stems here using the first digit of the marks. For example, 5, 6, 7, 8. Then mark a leaf here for each data value by adding the second digit to the correct stem. For example, 56, 52, 57, 69, and etc. Then put the leaves in each row in order from lowest to highest. And remember to include a key. Now, let's find mode of these data values. As we see here, the most frequently repeated number is 73, which repeated 3 times. So, the mode is 73. Overall, we have 19 values. 19 plus 1 divided by 2 equals to 10, which means that median is the 10th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th value is 67, so the median is 67. And to find the range, we should subtract the smallest value from the greatest value. The smallest value is 52, greatest value is 82. So the range is 30. Back-to-back stem and leaf diagrams can be used to compare two sets of data alongside each other. One set of data is read as usual, while the other one is read backwards. For example, 14 girls and 14 boys completed a puzzle. The time in seconds it took each pupil to finish was recorded. This ordered back-to-back stem and leaf diagram shows the results. So, here, scores for boys is 14, 14, 17, 19, then 27, 29. But for girls, it means 23, 25, 25, 28, 28, 29, and etc. And also remember, include a key. Now, let's find median for girls. Number of scores for girls is 14. So, by the rule, 14 plus 1 divided by 2 equals 7.5. It means that median will be average of 7th and 8th data values. So, for girls, 1, 2, 3, 4, 5, 6, 7, 8. 7's value is 31 and 8's value is 32. So median is 31.5. Then median for boys. Number of scores for boys is also 14, so median will be average of 7's and 8's values also. For boys 1, 2, 3, 4, 5, 6, 7, 8. So it will be 32 plus 33 divided by 2, which equals to 32.5. Then range for girls. The least value for girls is 23. The greatest value for girls is 44. So the range for girls is 21. Range for boys. The least value for boys is 14. The greatest value is 49. So the range equals 35 seconds. Frequency polygons are used to show continuous data, so they have a continuous scale on horizontal axis. Each frequency is plotted at the midpoint of the class, and then points are joined with straight lines. For example, Amin recorded the speeds of the cars that passed outside his house one day. The results are shown in the group frequency table below. First of all, let's find midpoint for each class. Here we have 25 and 30, so 25 plus 30 divided by 2 equals 27.5. Then 30 plus 35 over 2 equals 32.5. 35 plus 40 over 2 equals 37.5. 40 plus 45 over 2 equals 42.5. 45 plus 50 over 2 equals 47.5. And 50 plus 55 over 2 equals 52.5. Then, for each class, plot the frequency at the midpoint. For example, 27.5 is approximately here, and frequency is 1. So we put this point. Then, 32.5 with frequency 5. 37.5 with frequency 12. 44.5 with frequency 16. 47.5 with frequency 9. And 52.5 with frequency 2. And finally, we should join points with straight lines. So this is our frequency polygon. And the last part will be about histograms. Histograms are a bit like bar charts, but they are used to show continuous data. Instead of plotting frequency on the vertical axis, we plot frequency density, which is calculated using the formula. Frequency density equals frequency over class width. This frequency table shows some information about the heights of 30 adults. So let's find the frequency density using a formula. Here our frequency is 4 and class width is 10. Class width means like difference between 155 and 165. So it will be 0.4. Then here 3 divided by 5, which equals to 0.6. 4 divided by 5 equals 0.8. 9 divided by 5 equals 1.8. 7 divided by 5 equals 1.4. And 3 divided by 15 equals 0.2. And then draw a bar for each class and check that the area equals the frequency. For example, between 155 and 165, frequency density is 0.4. Then, for this class 165 and 170, the frequency density is 0.6. Then, from 170 to 175, frequency density is 0.8, and etc. for each class. So, this is our histogram. That's all for today. Thank you for attention and good luck.